When you are solving a system of equations, that is, finding where two graphs intersect, one technique you can use is called elimination. Here's what that looks like. You add the two equations to one another, and in this case, you're eliminating the y variable. When you eliminate the y variable, the only variable left is x. We can solve for x. Once we have the x coordinate, we can substitute x into either of the original equations and solve for our y coordinate and find that the solution, or the point of intersection, is going to be the point 3, negative 1. When first learning elimination, I know there's one step in the process that can seem like magic to a student. And it shouldn't seem like magic, this should seem like logic. And that step is right here. So let's take a closer look at this step and see why it's logical. There's a property in mathematics that says I can add the same thing to each side of an equation and the equation stays balanced. It's known as the addition property of equality. In this case, let's say I want to add 15 to the right-hand side. If I add 15 to the right-hand side, I need to add 15 to the left-hand side. Then the equation stays balanced. However, we can see on the right-hand side, 12 and 15 are like terms. They're both number terms. That will make 27. However, on the left-hand side, 15 is a number term, but 5x and 3y are both variable terms. There are no like terms to combine. So what I need is something that is equal to 15, will allow me to combine with the 5x and the 3y terms, and that is where I'm going to use the equality statements in the second equation. 15 is equal to 4x minus 3y. That is why instead of adding 15, I can add 4x minus 3y on the left-hand side, and I'm still adding 15 to each side. It's just that this 15 looks a little different because of what the equation statement says. Now I can combine my like terms on the left-hand side and make 9x equals 27 and solve for x. So just remember, when you're doing elimination, you're really just using the addition property of equality.